All right, perfect. So Kobai's semantic graph platform empowers you to better manage, organize, and curate all of your data. And it provides the best combination of innovative graph technology and intuition for user interface to make working with the data simple and easy. Kobai runs within a Databricks platform, and its enhanced data discovery and reuse and unique Gen AI features are all what the platform has to offer. So, with that, the three things that the Kobai team will be presenting over is they first want to spend the first 15, 20 minutes on introduction and the approach and architecture that they have with their platform. And then, following up with some case studies. The second section will be a demo of the graph platform. And then the final will be graph and AI integrations and demoing over their platform and their integration with artificial intelligence, and then a couple minutes left over for Q&As. I recommend the Kobai team leave some time for random discussion to happen in between as well. And with that, I will give it off to the Kobai team. Go ahead, guys.
Awesome. Thanks for the introduction and the opportunity to present to this group. My name is Parag Goradia. I'm the CEO at Kobai. I have Ryan Oates, who leads technology, and also Mike Fowler, who leads our customer engagement. So, we would love to share, as mentioned in the intro. Let me just share my screen and get started here. All right, can you guys see my screen?
Yes, sir.
Okay, perfect. So yeah, Kobai is a semantic graph platform. As mentioned earlier, all the customers that we engage with, I mean, everyone's looking to reach that data maturity, and they're on that journey to either connect all their data, be able to manage and curate it, enable data to be used by everyone, and then power up the AI ML insights. So how can semantic graph layer help? You guys are probably familiar with this, as a lot of you are deep in this space. So I'll just highlight. At the end of the day, our mission is to create that abstracted semantic graph layer that allows you to aggregate and unify both structured and unstructured data. So we do support time series integration too in this as a unique capability. Again, able to provide that contextual relationship with the business meaning and create that flexible, reusable ontology for better insights. So we've added a few capabilities that are unique, which we'll highlight, in the subsequent demo. At the end of the day, what we are educating our customers as well as the space and the partners with is the need to create this semantic data fabric. So as you have multiple functions within an organization and you have multiple data points coming in, the missing layer here is the semantic fabric. And Kobai allows you to create these in the form of questions very easily in a codeless and self-service way, where you can pick your domain, whether it's price, schedules, parts, quality, and be able to link all that together towards your business KPIs. Like in this example, it's on-time delivery. Could be reducing waste, and you can create that business scenarios and run your simulations or digital thread, as they call. You could do it around price hikes, poor quality, around parts, or even around a couple of, risk-based scenarios. So, this becomes that nirvana state of a connected enterprise where everyone can democratize and use data for their different needs and by different personas of the organization. But again, the fundamental foundation here is building that semantic data fabric. So the architecture is pretty straightforward. You have obviously the data sources. Everyone's familiar with those OT sources, IT sources, as well as engineering data and others. And you want to get that data in the best possible way in a curated form for consumption and decision making that's happening either in your BI space. You want to govern some, data on who can see what, data science needs, as well as some solutions. So where Kobai fits in within the AWS and Azure, cloud, especially with our partnership with Databricks and Snowflake, actually, is allows you to do these 5 steps. Be able to create that semantic ontology in a sharing mode, so very collaborative. Be able to integrate OT, IT, and any form of data. In a codeless way, capture that authoring and calculation so you don't have to learn Sparkle and other scripting languages, so completely codeless, and be able to then publish that for consumption in different forms. And at the end of the day, be able to do those simulations and what if scenarios. And most recently, we are adding a lot of capabilities around Gen AI, which we'll share in subsequent slides. Any questions so far? All right, I'll just proceed. If there are any questions, feel free to raise it now or later. So again, a quick sharing of the operational use case around predictive maintenance. So this is one of the customers we worked in with the Databricks team. Again, they're looking to reduce their downtime. It's an energy company. They have multiple sites generating power, and they have something called availability loss when the engine or that turbine is not running. So how do they reduce that downtime? Be able to allocate the right resources at the right time to address those issues and reduce their losses. So fundamentally, the challenge were twofold. One is around site of those frequent outages, availability, performance loss, what I mentioned. And then obviously there are the data challenges where they have data all over the place, different systems, plant systems, OT, IT, as well as engineering and maintenance, human resource data around skills and field service availability. So we, use this opportunity to start defining and introducing that knowledge graph and ontology approach, where we help build that business process, metadata information using ontologies, and be able to map data and consume it upstream for their solutions. Again, a simple flow, if I share with you how we did that, is, oops, okay. Sorry, someone's coming in. Is say you have OT data, you have IT data and engineering data, you have resources managing those data sources in a raw form. You first start with building out that semantic model and the ontology. We'll show you that in the demo briefly, and be able to map those entities and relationship to the actual data sources. And these can happen independent, but it's all happening within the same graph. So you have the subject matter experts owning the ontology, and you have the data engineering experts owning the mapping of the data. And as that happens, we ingest and instantiate the graph, or basically persist it within the Databricks ecosystem. And this step from 1 to 3 can continue to happen as new sources come up or new entities are defined in the ontology. As that process takes shape and the graph is instantiated, folks within the organization can start building their questions and queries. Again, in a very graphical, codeless way, you can pick the entities you're interested in, be able to define those calculations and the business logic, and be able to then publish it out in different forms, either in your Jupyter Notebook, so we have very tight integration there, or through APIs that can be consumed in Power BI or Tableau, or native Delta views, which create that SQL view if you're interested in that, and publish it out as data sets, data products, or in a marketplace of sorts, or even into your solution. So steps 4 to 6, again, are independent, And this helps you start democratizing that data across the organizations to help those decision makers or day-to-day activity to continue to build their questions or their queries in the platform. So again, two distinct kind of steps or personas that work within the tool.
Prague, I
We've
have a question.
also,
I have
yeah,
two actually. I have two questions. So
yeah,
first, in the use case with the wind turbine
yeah.
organization, did you find it challenging to get the data initially to then build a semantic model with it?
So data access is always, unique and interesting. So I would say every customer is on their own journey to move data to the cloud. So in this particular case, some of their data was in the cloud and some of their data were on some on-prem systems. So we did end up, again, that was the longest pole, if that's what you're trying to ask in
Yeah.
this whole process, because finding where the source of the data, getting that access to that data, and then mapping it, you have to make sure the organization understands where those silos are, right? So again, it depends on the maturity of the company's journey. Sometimes there's a team that manages all the data and they know where the data is. And sometimes you have to work with them to find where the data is. But once you identify where those sources are, it's very easy.
And then my second question, as far as publishing views, step 5 that you have listed here, does the Kobai graph platform happen to manage this, or are you thinking that this step is independent? The company would take care of it themselves as far as displaying said data in their own needed ways.
So if I understand your question, you're asking who takes care of the publishing of the data or
Yep,
the
to view
output?
it, to consume it and look at it
Yeah.
and everything.
So Kobai provides a couple of things here. So one is we do provide, and we'll show you that in the demo, the API and the output as a SQL view in Delta view. So you can then just take that API URI and pull it into your Power BI or Tableau or notebook. And we'll show you
Okay.
that in the demo, right? So
Yeah.
that
Okay.
Kobai takes care of that publishing, right? And we do that on AWS and Azure using, whatever they provide in terms of API publishing.
All right. Thank you.
The customer is responsible for taking that and then feeding that into either their Jupyter, Python code or, notebooks, or taking that SQL Delta view and pulling that upstream into their solutions. That's on the customer. But we provide that endpoint with the key. And we have also added the governance capabilities. So we've integrated with, we can integrate with your policy engines. We've done that with a product called Immuta, and which is a partner of Databricks. And even we integrated with the Databricks Unity Catalog, where you can actually, anytime a new entity is defined in step 2, we can add that to the policy if those exist, so that anyone in the organization that has published that property from the ontology, and if that property is getting called in any of those API views, it will ask for authorization before it can show you. So one of our customers is a large defense OEM, so we have ensured that there is security around who can see data when and where. Does that answer your question?
Yes, thank you. And I think that there might be a question in the chat. Um, is the insights of the data available in time series?
Yes. So we are probably we treat time series as a first class citizen here because we come with an OT background. So we have integrated our product with Aviva's OSI historian, OSI Pi historian, and other historians. So we do treat and we can integrate historian data along with your other OT data and IT data.
And then there was another question. Thank you for answering that one. The question from Peter is, so far it seems like that this platform is a semantic data warehouse for analytics over existing data. And his question is, can new data be created and managed in the knowledge graph itself? assume through the platform.
Absolutely. We differentiate it as standard entities that you create as part of the ontology creation process. And we are an RDF graph, so we do follow those open standards, but we don't expose the Sparkle or the other entities. It's all codeless. The other part, so there are standard entities that people define, or SMEs can define, but then there are calculated entities. That's what you create in the tool, and we show you that also in the demo. And those entities can be either outputs of the notebook, meaning your output from your AI forecast or prediction of what you have, or some other calculation that you may exist. So the tool allows you to introduce calculated entities and persist it, as well as standard entities with its relationship. So yes, you can create new entities within the tool, and you can persist it as new value add entities. And then people can just use it as, in the queries. So if someone creates a forecast and stores that in the graph as an entity or property, anyone else in the company, if it's exposed to them, they can use it for their questions.
Thank you.
So with that, I'm going to hand it off to Mike Fowler to show you guys a demo.
Everybody see my screen?
Yep.
You sure can.
Okay, perfect. So we're going to do a quick demo. If there's interest after, you can always reach out and we can do a more in-depth one, but just in the essence of time, this is going to be a quick high level. So we're going to look at a few different aspects. We're going to look at how an ontology can be created by end users. We're going to look at creating questions, which are essentially queries, and how we can build those codelessly, tying into data from multiple different data sources. And then finally, we're going to look at how we can start sharing the outputs, either through those published APIs or views, or as visualizations within the tool itself. So we have the ability to create ad hoc visualizations. So again, those are kind of the three areas that we're going to highlight as part of this demo. Again, I'm going to keep it relatively high level, but feel free to stop and ask any questions as you see fit. So here we're looking at an ontology that we've created. This was a use case around kind of workforce management and making sure that the organization had the right number of people at the right service sites in order to be able to efficiently manage work orders. So it was kind of like a workforce management type scenario that this demo got built off of. At a top level of the ontology, we have domains. So they can be tied to business units. So in this case, we had one with human resources, finance, engineering, but we also have some more abstract ones. We have documentation, asset management. Again, they can be called whatever is familiar to the organization and whatever they need to call them. To create a new domain, it's as simple as hitting this new domain button, giving it a name, and then you can optionally select a color. I'm going to drill into human resources just because it allows me to kind of talk about some of the aspects that we have to the tool. So within human resources, we have several different concepts. So kind of fundamental to HR, for example, we have the concept of a person. Person has properties, first name, last name, email, and then person has these relationships. So they could have certifications, they could have skills, but again, they don't have to be one-to-one. So they could have a nationality tied to a country, or they could live in a country. To build out the properties or the relationships, again, it's as simple as hitting this add button, giving it a name, selecting the property type. And as Parag mentioned, we treat time series as kind of a first-class citizen, or in the event that you want to create a relationship, and then which domain and which concept you want to create that relationship to. So that's kind of how you can create concepts, add properties, and add relationships. In the ontology, all of these solid lines that you can see are where there's been relationships. You'll also see dotted lines. So we support inheritance, so similar to all of your object-oriented principles. So I talked about a person, but within an organization, there could be employees, contractors, candidates, which are all subclasses of person. So if I was to open up this employee, we can see here that I have this inherited section. So I'm inheriting all of the properties and relationships that a person have. In this case, I actually have a workforce concept that's sitting in between, which has things like employee ID as well. But then as a function of being employee, they could have a job title, maybe a hire date, maybe they have additional relationships that they manage employees or manage contractors. So this allows us to create questions and against higher level concepts such as the person, or get more granular as necessary, where we might be wanting to look at the employee, the contractor, the candidate in specific or individually. One thing to note, in this particular case, the inheritance is within a domain. That doesn't always have to be the case. So for example, I have an asset management domain where I have the concept of an asset that has a name, serial number, and description, along with a few relationships. I can take that same asset and I have an IT domain, for example, where I have a server. So I'm inheriting from all of those assets. So we can inherit from multiple source parent concepts, and then they can be in multiple domains. One last thing, Prog mentioned that we have integration with data governance tools. We can also do some level of that within the tool itself. So for example, I have social security number, might be a secure property you don't want everybody to see. So we can tag it as HR or PII or something like that. And then only those users that have the same tag can see the data. So we can do that at both a property level as well as a record level. Any questions so far? All right, I will keep on moving.
Somebody got the hand up.
Oh, yes.
Okay, a question over here. This graphical tool to build an ontology is very nice if one person uses it, but if you have different people in the organization trying to gather to build an ontology, and they may have conflicting views on how things should be structured, and maybe need some way to organize their work together. Like as programmers, we have Git, and maybe they have some process where they can discover and resolve their different views. To which extent does your platform support these kinds of processes, or do you just have one shared UI where everybody can change everything?
So with each one of these domains, you'll see this share button up here. So once a domain's been created, so in this case, human resources, I created it, I'll have the ability to edit it. Nobody else can touch the human resources domain unless I've shared it with them. So we typically, when we're working with customers, find the subject matter experts within each of those domains, say pick 2 or 3, for example, and that way you have 2 or 3 people who can collaborate within a particular domain. So whether it's finance or engineering or supply chain or whatever the case may be.
Okay, 100% makes sense.
Any other questions?
Yeah, to backpack on that original question, is there, if I was using the site and somebody else was using the site to create and edit one specific domain, human resources in this example, are conflicts resolved in a, in some fashion, or is it like, let's try to keep one person using it at a time?
Well, I mean, you're going to see it in real time as they're in here editing it. So if people are adding the concepts, their property, the other person's going to see it. So again, by restricting it, what we found is that by having a couple of people, they can usually collaborate, and each one of them is going to be working on something different. So by keeping it to a couple of subject matter experts, we don't really have collisions that we've seen today.
Yeah. Okay. Thank you.
And again, everything we can snapshot the ontology. So that, I mean, we can schedule snapshots or have regular snapshots, so you have version history over time. We can also integrate with some other ontology tracking tools like Miro or something like that that can do some of that as well.
Cool.
What was I gonna say? Moving on to questions. So again, demo, I've created a whole slew of questions. Here they are kind of organized by domain. So if I open up the operations domain, for example, here are all the questions that I've created. You can see a lot of these questions span multiple domains. So if I look at this all drill work orders, it's spanning concepts that are in the human resources, the services, the drilling, and the operations domain. If I open it up, we can see here that this question was completely graphically created. So there's no Sparkle or SQL or any other type of code required to create these questions. If I click on the work order button, we can see that all of the tiles with the plus button are ones that haven't been added, but that they could be added. All the ones that don't have the plus button are the ones that are incorporated in the question. So you essentially just navigate, pick a starting point, and then navigate through the ontology that's been created, selecting which properties and which relationships you want to bring in. Once you start building out some of these questions, you then map it to your data. So for each one of these properties, in some cases, I'm mapping it to 3 different data sources. In other cases, I have a single data source. So for example, for work orders, maybe I have Maximo or other ticketing systems within the organization that I want to map at work order ID. We'll go through the one step of kind of adding each of these data sources. So we support a multitude of different relational databases, cloud CSV. So if you have information sitting in like an Amazon S3 bucket or an Azure blob, file upload, so CSV sitting around, or even APIs. So we can connect to external APIs, or if you have Salesforce or SAP with a web service, for example, you wanted to call and bring in data from that, we can do that as well.
Hey, Mike, we have a hand up again.
Yep.
Okay, one question. If people have created these queries and we change the ontology and sort of want to change some of the concepts, maybe rename them, delete some, add some, how does the system react to a changing ontology with existing queries?
It will not allow you to do anything that's going to destructively affect any of the existing queries. So it'll basically highlight where there's going to be problems and allow you to kind of resolve them before you go make those changes. Renaming will be okay, but if you're going to like delete a property, for example, or delete a relationship, it's going to highlight all of the questions that are going to be impacted so that you can go address those first before you delete the relationship.
Mm-hmm.
So do you support versioning and branching and such of the ontology so you can go and figure out your changes and make sure they work before then you have to go back and fix everything that's been deployed or developed since?
Yeah, so as I mentioned, we can't take snapshots. We put it in a kind of a JSON format. So some of our customers do have a couple of environments. They'll have a dev environment and a production environment. They'll make some of their changes in the dev environment and then take a snapshot and use that to import into the production. So from a change control perspective, those snapshots bring in all of the ontology, as well as all of the questions and configurations as well.
Okay, thank you.
Mike, before we get started again, we got 2 more questions. Oh, never mind. Someone answered it in the chat. Never mind.
Just to keep time, check on time. Okay. Again, we map the data, we ingest it to build the graph, and then with each one of these cards, we can do things like filtering. So I could filter on properties or other values. We can do things like aggregate. This demo environment doesn't have it, but we've recently introduced window functions. So we have different capabilities to do different levels of aggregations and things like that. As Prog mentioned earlier, we can also do runtime calculations. So I can create mathematical functions on numeric values, for example. So we support all the basic math, plus we have some different functions for both mathematical operations as well as date time. So things like number of days, weeks, etc., between 2 dates. Once you're kind of done building your question, you can preview it. So in this case, my work order ID, I had a dynamic filter, so it gets applied at runtime. I'm going to ignore that for now. I'm going to get a preview of all of my data. Maybe I'm ready to share it. I'm happy with how my data set looks like. I can hit this API button, and here's that API endpoint. So now I can use it and feed it into other enterprise applications, Power BI, Tableau, whatever the case may be. This can also be published as a kind of a curated view within the Databricks or Snowflake backend as well. Finally, we can create visualizations. So we have the ability to create a multitude of different visualizations, which can be done kind of ad hoc and then used in, if I switch to Tower here, we can look at Tower. So again, here I'm looking at work orders and percentage of men started on time, how many upcoming work orders. So each one of these cards corresponds back to a question. We can see who the author of the question is, so I know who to go to. But we can also open it up and we can see how the question was put together. So if I'm an end consumer, I can see the logic of how the question was put together and how they are achieving the answers that they're getting. One last thing, I can go to operations, we kind of have the ability to drill down and create some visual digital threads. So if I pick a country, so here I'm looking at number of engines and compressors and things globally. If I look at France, for example, here I'm looking at just for France where my efficiency is by city. I'm going to shortcut this and put a few additional filters in here. In this case, I'd want to drill down to, to see what drill or what engine or something is impacting. Hold on, why isn't that working? Hold on, maybe I do need to do this because what site is 10? That's 2070. 15, 18. I'm gonna shortcut the rest of these filters. And when we get into that time series, now I've kind of determined that this particular engine. So here's where we're bringing in time series information as well as the IT information, such as the service cost, how many issues and how many work orders have been experienced in the past 12 months. So again, all these visualizations can be created here, or we have customers who are tying it into their Power BI or Tableau and doing their visualizations there. And with that, unless there's any other questions, I'm going to turn it over to Ryan.
Thanks, Mike. And any questions on that bit before we move on? Anything about how we, create the model, ask questions, that sort of thing?
I did have a question. Sorry, before you get started, Ryan.
Yeah, sure.
I had a question about like complexity. If we at Semantic Arts have a good example of like time cards and rolling them up to get like complete aggregates and pay periods and whatnot. And so it's a lot of subselects. It's a lot of just, complex queries. As far as the questions go, how far have you been able to push it?
Quite far. The combination of large numbers of concepts, large numbers of properties, but also, sophisticated inheritance relationships between the two, where, maybe some of the most complex questions we do are industrial customers talking about different types of assets that they then all want to also analyze at the parent level on the things that they have in common. So, yeah, I mean, we could look at use cases you have in mind, but certainly not designed just for simple, obvious questions.
And then to finish on Yakov. Did I pronounce
Yakov. Thanks, you said it right the first time.
Thanks. So he had mentioned the issue of like changing the ontology and then having questions having conflicts with the changes in the ontology. Have you dealt with a use case or any of the current clients who have gotten so deep into it that they now have this huge list and array of like questions being built, and then they make changes, a lot of changes? Has that situation ever arisen, and if so, how was it dealt with?
Absolutely. One of Kobai's earliest customers was a very sophisticated aviation company. They're a defense contractor, and they've had several generations of their ontology. And so, several years ago, we had to work with them to understand what that was going to look like. And, probably our professional services folks wrote a few scripts, but we've learned from that. And so we have more tools in there now to let you do refactoring of the ontology, moving things between domains, changing how inheritance works. And there's automation in the back end when you say want to rename a property that then sort of ripples through and make sure that to the extent we can just automate fixing that, we can do so.
Cool.
I had one quick question with regards to creating relationships between the classes. Is how expressive and constraining can we make those relationships? And I'm alluding to, the capability you might find in Shackle or some of the other standards evolved from that.
Yep. So, I think you can see Kobai is aimed at exposing knowledge graph technology to sort of enterprise users who aren't necessarily deep ontology users. And so there are places where we have not supported the full expressivity of something like OWL or Shackle on purpose, really. And so one of the primary places that comes in is the sort of one-to-one domain and range with relationships, right? So, you can have a relationship to a parent that then works with the children, but you do lose some of the expressivity that is possible, like in Shackle, forming shapes and relationships, that sort of thing.
Okay, good to know. Thanks.
I will say we have a list of things that, we have looked at. Okay, when we hit this use case, we're going to implement this because, all these things are possible, right? It's a matter of how many of these levers do you want in the UI for the kind of users that Kobai experiences. So, that has been a place that hasn't been a roadblock for us thus far.
Yeah, and we're kind of coming at it from the machine consumption of the models too. So the more
Sure.
constrained and explicit you can make things, then the more intelligent your algorithms can be.
100% agree. Yep. Okay. With that, I'm gonna
We have
share
one more
my.
hand.
Oh, I'm sorry, I missed that one.
I have a question over here. I sometimes, as a programmer, have seen tools, graphical tools, which make it easy for some users who don't have too experiences writing code and text, make it easy to see what they do. But when used in complex situations, I found it sometimes very limited what you can do. So if you have always to use a mouse, you can't copy paste part of the text and part of the program and reuse it in some other places. And sort of when I see as a programmer a graphical tool, I sometimes feel scared. Wow, if I get into complex work, does a graphical tool support my work or not? So my question is, you could say, you are not target user. That's not our problem. You could say, well, our graphical tool is actually supporting very well these use case. So for managing complex data, you don't need a text-based UI. Or you could say that maybe in the Jupyter notebooks, data scientists can actually ask all his questions, access all the power of your system in a programmatic way, and then once he resolves what he needs, can export it maybe also as a query, as a JSON file or whatever. Sort of how much are we tied to using the graphical UI as the only UI to use, and how easy is it maybe even for programmers to live with that?
It's a great question. We have found that we can strike a balance between providing easy to use features for the people who are not programmers with more complex features still in the UI that can cover the vast majority of the use cases that we see. And that one, to me, that's important to maximize that, because even if a programmer can go away and do it, we find that the really interesting complex problems require collaboration between technical and non-technical people. So if you take away into a coded black box, that's very difficult to come back to the team and show them what you did. And so, we're continually adding things. Mike mentioned window functions. We're now taking our sort of built-in calculation engine that's very visible and expanding that to any analytic you can run in Databricks, you'll now be able to do in our UI. Things like sub-questions. You talked about reuse, right? Taking a question and being able to treat that as kind of a semantic concept that you're able to bring into another question and extend it. All that said, what I'm going to show you here is how Kobai is immersed in the Databricks ecosystem. So, all of the data that's in Kobai is available to you with any tool in the Databricks arsenal. So it is certainly not uncommon for someone to take data out of Kobai as a starting point for a machine learning exercise, right? And they're going to write some code around this. They're going to derive some new values and then map that back into part of the ontology that they build in Kobai.
So
Does that make sense, Jakob?
100%. Yes. So what I get is that I understand that if a data scientist wants to write code, he can get his hand on the data and write code,
Sure.
But you don't want to support that as a prime use. You want to have people to work together and as much as possible to use a graphical UI. And when a data scientist says, well, I can't do what I need to do, you are listening and you are improving the UI and you see it works, sort of that people are happy with UI, even if they are more technical.
100%. That's always our goal.
Okay, thanks.
Tim, I think you had a question as well.
Yeah, I was asking from an architectural point of view, looking at your picture here. So I'm sitting in Databricks today, and I've got all kinds of data in there. Do you actually leave the data in place in the various, blob stores, delta tables, whatever, or do you lift it and put it into the graph, even though the graph lives in Databricks?
I forgot I'd started my sharing, Tim. Thanks for reminding me. Yeah, my first topic here was highlighting that Kobai is the only graph engine that is architected for the lakehouse architecture. So we support Databricks. We also support Snowflake, and we manage a schema in those environments that stores graph data, that leverages the architectural capabilities of the lakehouse to make graph queries extremely performant. And you get things like cheap storage, scalable and elastic compute, and separation of compute. Right? It's not uncommon for our customers to have query and ingestion running on two different work clusters, and then any data scientist connecting to it maybe brings their own cluster with GPUs to the table. To answer your question, when the data is, let's say it's an arbitrary API. Mike's demo has weather network data. We have a service that goes and gets that and pushes it into Databricks. If the data is something that Databricks can go and get itself, let's say it's CSV files in a AWS S3 bucket, then we just push the instructions to Databricks, and it goes and gets the data, and yes, pulls it into our schema in Databricks. The next phase of that, which is actually something that's in development now, will be for some data sources, we're going to adopt this Databricks Lakehouse Federation strategy, where we will dynamically, or maybe say it's virtualization, we'll go and get that data still within Databricks, but in other tables at the time. And I say that's kind of under development, also under evaluation, because our schemas are designed to execute graph queries quickly. We just need to learn a little more about what the performance impact to our customers will be on letting them sort of have that virtualization to other lakehouse sources.
Oh yeah. Okay. So let me clarify then. So in our environment, we have large corporate data lake, got a bunch of tables in it already. And the first question IT will ask for an application like yours will be, are you going to copy the data to another place, whether it's in our own Databricks instance, or make a copy of the data, or are you going to operate on top of that table structure as it sits today?
Yep. So the current version of Kobai would make a copy of the data. It would not leave Databricks, right? So you're not paying egress and ingress costs, but we would make a copy of it. We are developing the capability to not have to do that really for anything that's referenceable in Unity catalog, right? So we sort of use that as an engine to be able to share data from other places without re-ingesting.
Okay. Perfect. Thank you.
Maybe I will just keep going here. So you get these benefits of separation of compute, cheap storage, elastic compute. One of the other benefits that you get as a data scientist or somebody on an AI team is that Kobai data is already embedded in your primary compute platform. So, I mean, super high level diagram here, but when you ingest data into Kobai, it's in Delta tables and Databricks. We have a big aviation customer that was then taking that and building a graph neural network off of that data. And we're able to show them just removing the bottlenecks, right? They had another graph in place where there was an in-memory analytical service that needed to go kind of project that data into memory so that it could be pulled out into a graph neural network in Databricks. And we dramatically reduced the amount of code that they had and, the cost and sort of efficiencies lost in moving that stuff around. So I'm not going to stay with the deck here. I wanted to mostly show some of this stuff in action in our SDK. So where Parag and Mike kind of focused on the codeless interface and how we work with customers in Kobai, I'm going to move and talk a bit about the backend. So let me stop sharing that. And Kobai is not fundamentally a Microsoft Teams company, so hopefully I'm sharing the right thing here. Can you guys see my screen?
Yes.
Okay, like awesome. Notebook. It is a Jupyter notebook, yes. So I created a notebook for us to walk through. I'm just going to highlight a few things as we go and just kind of use this as a tool to talk about some of Kobai's data science and AI capabilities. So first thing I did here, we have an SDK for Kobai. It's open source. It's available on PyPI. So that's been installed. And then we also facilitate sort of SSO enabled authentication. So I'm just going to do this live here. And it will prompt me. Hide that. Oh, sorry, I hid that panel. There we go. It's going to prompt me just to log in with SSO. So we don't need to store, development keys or anything in any unsecure way. We will just see now that we've successfully authenticated with the Kobai server. And then I'm going to run a question by name. When we do kind of technical demos, I have an environment that has an ontology in it about Lego toys, right? So different sets, they have minifigures in them. They belong to different themes like Star Wars, Harry Potter, whatever. And, there's some simple analysis in there like, how many sets did I have by year and theme, right? So I can look in here and say I had this gear theme or superheroes from Marvel. And so I'm going to do kind of the same thing in the notebook here. So we have an SDK function that will take the name of a question, and I'm just going to run that. Great. And so what this did was execute this question and return the result to me in a Python dictionary. And so if I'm a data scientist, that's kind of interesting, right? I can take that, I can do whatever I want on top of it. But if any of you are experienced with like scalable compute, data science compute in Spark, that's not the most efficient way to do it, right? I have now a dictionary object on the driver node in my cluster. I don't really have something scalable. So this other very, very similar function is going to run the same question, but it's going to give me back a data frame. And then we're just displaying that data frame. So now I have the results of this question in a distributed Spark data frame partitioned across my cluster. So now I can go at it at scale, right? And so there's very little friction between kind of having your data in Kobai and having your data in a scalable compute platform that you can work with. I guess the next thing here is just to sort of show, we can interact now with anything else in the Databricks ecosystem. So this is not really a part of Kobai. This is the open source Plotly library. But because we have the data in a data frame now, sort of the world of data science tools is open to us, and we can visualize, we can train ML models, we can do whatever we like in that regard. Kobai is currently very focused on generative AI. Specifically ways that knowledge graph can make AI work for enterprise. Our customers are typically large corporations that have a couple of big challenges with AI. One is running it on private data, and one is the problem of validation, right? This magic black box gives me an answer very quickly, but what do I have to do to actually confirm that that's the right answer? And so we're mostly working in areas where sort of knowledge graph plus LLM gives unique capabilities to solve those two challenges. Just for time, really, I'm not going to get too far into that side today. But if there are folks wanting a deeper dive on that, we just published a 5-parter on Medium about sort of trends in graph AI, different approaches to graph RAG, things like that. So we could provide a link. Actually, there's a link on our website if that's something that's interesting to people. What I thought I would do today is just touch on a couple of very simple things that can be done with AI. This idea came from one of our customers of a follow-up question, right? They've built some questions in Kobai using the UI that Mike shared with you. And, we're going to be adding this feature in the UI, but, early days, just available here, to ask a follow-up question. So that same question I had before, what are the number of sets by theme and year? But I have this other question now, which year had the most Star Wars sets? And so because we're integrated with Databricks, one of the things our AI can do very seamlessly is take the data set that you had above and this follow-up question and feed that to the Databricks DBRX model. And it's taken that data as context and replied that, 2015 was the year with the most Star Wars sets came out. That was probably when one of those movies came out or something like that. So, we have other capabilities that maybe aren't as much in the demo around taking semantically enriched data and creating semantically rich vectors for RAG. That's certainly a pattern that our SDK helps facilitate for customers building their in-house LLM tools on top of. And the other one I wanted to highlight is our integration with Databricks Genie. So Databricks Genie is a text-to-SQL tool, right? Just show us where your data is and then have a chat experience. And, they're a close partner of ours. One of the issues is there's no semantics to really describe the data, right? The schema, the relationships, foreign keys, primary keys aren't really enough to help translate, what the data really means and what the user is actually asking about when they type a question. So via our SDK, if I click this row says generates Genie views. So what we're doing here is taking each class in the ontology, our concepts, and we're going to create tables about each one of them. And we're going to fill out comments and set metadata about what they mean based on the model. we're going to really create kind of the ultimate enriched, tabular data set for this thing. And then with this second call, I'm going to stand up a Databricks Genie environment. I'm going to pass it some sample questions so it sees how we typically analyze data. And now if I just open this URI in another tab, this is a Databricks product, but we've had a lot of success with kind of bootstrapping it with Kobai. So normally you would come here to data here, you would add tables, you would have to go to Unity catalog and fill in the meaning of each particular column. Whereas based on the ontology, we've done that, right? So if I show you here, I have a table set up in Genie for everything in the model, right? I've got Lego sets here, and we've added some description. We can lay out all the properties, and each one of those has a description. So the punchline is just start that compute. If I come here and say, which set in the Star Wars theme has the most parts? Right, so Genie will then use all of this context that we've given it from Kobai. It'll design a SQL query around that and give us an answer. So it's telling us what it's done. I don't know if you guys have seen Genie or other sort of text to SQL tools like this, but you can, oh, that's good. Well, it obviously didn't build a very good query that time. This is some of the fun with large language models.
Ryan, while that's running, the documentation for the Python package, the Kobai SDK, is that on the website? I was trying to find it.
It's not on our website. It's on PyPI. So if you go to PyPI and search Kobai-SDK, there's a getting started page. There we go. It worked that time. So it's pulled out the site that has 5,400 parts. If you go to PyPI, the methods in it are documented. There's also a getting started page that helps you walk through a demo of how you can pull data out of the data mix marketplace to make this integration work without actually having Kobai. We have kind of a demo mode that doesn't require you have a Kobai service.
Cool, thanks.
So I feel like we're tight up against time here, and we want to leave time for some last questions. That was all I had to share today on AI. Any questions about that stuff?
I did have a question.
Sure.
As far as the models or the even the transformers that you would use to vectorize any of the data coming out of Kobai or from the data sources themselves, are they interchangeable, or is this completely Databricks related? You have to use whatever is available there.
No, so the default of our SDK would be to use Databricks services for customers that are deployed in Databricks, just because that's kind of a seamless experience for them. But I mentioned, we have an aviation customer who doesn't want to use commercial cloud models. They have their own, or they have their own instance of them. And so what our SDK uses is LangChain objects. And so we provide through different functions the ability for you to execute our chain, where some of our value add pieces are how we retrieve data from the graph, how we build a prompt to help the LLM understand graph data. But if you want to then pipe that to the next step in the model, if you want to just substitute it in a different LLM, that's fair game. Yeah.
Cool. Yeah. Nice.
We appreciate all the good questions today. Any other questions anyone has before we run out of time? Okay. All right. Well, thank you. Thank you for your attention. We always appreciate a session where people are engaged and know something about graph coming in. Always helps for good questions. I think you have our contact. Please feel free to reach out if there's anything you'd like to follow up on, or check us on our website.
Thank you very much.
Yep. Thank you, guys. The video will it is recorded and it will be posted on YouTube, so everybody can look back and see everything.
Awesome.
Thank you, guys. Thank you, Kobai team.
Awesome.
Yeah,
Thanks.
super cool tool.
Thank you very
Thanks,
much.
everybody.
All right.
Bye.
See you guys.